Welcome back to another mission of physics. Today we will be seeing thermodynamics. The problem is the next one. The active element of a certain laser is made of glass rod 30 centimeters long and 1.5 centimeters in diameter. If the temperature of the rod increases by 65 Celsius, what is the increase in A, its length, B, its diameter, and C, its volume? Assume the average coefficient of linear expansion of the glass is 9 per 10 minus 6 Celsius. And, well, let's get started. First, we have to understand the problem. We have a rod of glass, and certain temperature is going to be applied in here, so it's going to expand. This would be the original rod, and then it expands and it's in its length and diameter, amplifying also its volume. So the data that is given is length equals 30 centimeters, diameter equals 1.5 centimeters, and the difference of temperature is 65 Celsius, and we seek our difference of length, difference of diameter, and difference in volume, knowing that the constant of the coefficient of expansion of the glass is 9 per 10 minus 6 Celsius. We have this little formula over here, which says that the difference of the length equals the coefficient of expansion of the material per the initial length per the difference in temperature. So we're gonna apply it to the height and to the diameter. So as you see, a length equals to a height, which is given to us. So we just apply the formula in here. We have the coefficient of expansion, the initial length, and our delta t. As I said before, we just calculated which, and we can convert it to centimeters, which would be 0.175 centimeters. We do exactly the same thing, but with the initial distance on the diameter, and this would give us a value of 8.78 per 10 minus 4 centimeters. The volume is some more tricky part. We have also the same formula, volume, but since we're applying a length in 3 spaces for the area and the altitude, it's like we make this 3 times. So we have to do delta volume equals 3 times the coefficient of expansion, because it's expanding in 3 places, per the initial volume per delta t. So what's gonna be our initial volume? Well, we have to think mathematically in the form and the shape. In this case is a cylinder, which formula of volume would be the area, which is pi, per radius, which is diameter over 2, squared, and then per height, which would give the volume to the figure. And this way we would obtain this formula, in which we could now substitute and get the result. Well, and we do as so, which would give us a value of 0.093 centimeters. I hope this helped, and we'll be seeing each other in another mission of physics.